everyone, and welcome to another episode of ADAR Unveiled. I'm your host, Chrissy Hudson, and as always, I am joined today by ADAR's executive leadership team, Dan Kelly, Doug Farrington, and Ari Boss. As always, we have time reserved at the end of today's episode for your questions. If we don't get to your questions, please drop them in the comments below and we will tackle those as soon as we wrap up here. All right. Before we dive into today's discussion, I want to take just a moment to reintroduce our ADS or acoustic dehydration solution technology, because we do have a lot of new viewers every episode. So ADAR's technology is very unique. We offer a 3-in-1 solution that dries, pulverizes, and sanitizes materials in a single process, all without the use of fossil fuels, heat, or harmful chemicals. It is a game changer in material processing. On today's episode, we're going to be talking about the incredible value that ADS can provide. We're able to take waste materials and convert it into valuable end products. So that's what we're going to be talking about today. And on today's episode, we're specifically going to be focusing on seafood waste, fruit pomace, and wood chips or wet bark. So to kick off our discussion, we're going to start with seafood waste. I'm not sure if you guys realize it or not, but the US has the largest market in the seafood industry. And every single year, the US produces over $11 billion in processed seafood. That's a lot of seafood. But have you ever thought about what happens to that waste after processing? We're still talking about nutrients, minerals, and valuable components. But in reality, a lot of that material is incinerated, it is thrown in landfills, or it's occasionally tossed back into the ocean. So instead of processing those materials into something great, like we can, a lot of people are wasting those valuable nutrients and minerals, and instead upsetting ecosystems in the ocean, causing greenhouse emissions, causing some funky smells out in the environment, and taking up valuable landfill space. So we want to change that narrative. Let's talk about what you can actually do with seafood waste. Doug, you want to kick us off?
Sure. Yeah, thanks, Chrissy. Well, seafood waste, really, I'd break it down into 3 different categories. There's the hard shells like oysters, clams, mussels. There's fish waste, so leftover fish or spoiled fish. And then there's crustacean shells, so shrimp and crawfish and crab and lobster, etc. So let me maybe just start with the hard-shelled items. And really, those can be processed by our machine and turned into a fine powder, which has a lot of calcium in it that could be used as an additive in chicken feed for strengthening eggs and so forth, but also could be used in things like green building materials. If I take the second category of just spoiled fish, fish waste, leftover fish from processing, our machine can turn that into a dry, odorless, and sanitized or bacteria-free material as a powder and can be used as a feed, a high-protein feed source for livestock and pets and so forth. So a lot of valuable material there that today goes in a landfill. People are paying to have it hauled away. And lastly, for the crustacean shells, and we've done a lot of testing in this area. Once you process it with the ADAR equipment, you turn it into a high-protein chitin powder. And chitin, along with its deacetylated derivatives, chitosan, can be used for many things, such as biomedical, nanomedical applications, but also in cosmetics and batteries, any kind of polymer. It's a world's largest resource when it comes to natural polymers, but also in nutraceuticals, pharmaceuticals, potentially in packaging. It's got a lot of strength and can be used in things like heart stents and so forth as well. So a lot of valuable materials that can be made from seafood waste.
Wow. To think that you can take seafood waste that's currently being thrown in the ocean, thrown in a landfill, totally disposed of, and create that many different things across that many different types of industries is pretty incredible. And unfortunately, a lot of companies are missing out on that opportunity. Which kind of brings us to our next question. What are the economic benefits of processing that waste material with ADS versus those current disposal methods that are at play?
Yeah, I'll take that one. I won't repeat all the different possible use cases that Doug just mentioned, of course, but the economic benefits are quite simple. It's either cost savings or revenue generation. So either way, ADAR is an ROI for the customer. And so from a cost savings perspective, quite simply, we make the waste product less heavy, less water weight, and simpler to throw into a landfill if, unfortunately, that's what you're doing with it. Of course, you're losing a lot of valuable resource that you can sell into the marketplace. So, but if you still choose to do that, quite frankly, we lessen your waste tipping fees. On the revenue generation side, it's really what Doug just explained. We're creating additional revenue stream opportunities from a waste product that currently doesn't have solutions today, from organic fertilizers to nutrient-rich aquaculture feed to renewable energy sources. So those are really the two different ways in which the economic benefits are there for the producer. And then, of course, the local economy. We talk about creating new jobs, great economic growth within the area because you're opening up new side streams of revenue for the local economy, and that helps everyone throughout the entire system and supports a circular economy, both in your local community as well as in your region.
Yeah, this is kind of like a textbook circular economy diagram, right? Literally taking waste, sustainably processing it, and putting it back, which is pretty awesome. So,
Right.
Other thoughts as far as maybe environmental benefits? You know, we've talked about the economic benefits. What about the environmental benefits of processing via ADS?
Maybe I'll take this one, Chrissy. You already mentioned that the US is the biggest provider of seafood in the world. And you know me by now a bit. I always try to find some background. So I dug a little bit into the numbers. And I'll give you a very brief, quick overview. Won't take too long. Let me share this with you. So I look at the waste only, and you see here that almost 1.6 million metric tons, so that is about 2.5 billion pounds just from the US is fish waste, and 470,000 metric tons is shellfish waste. And you see the numbers below that, how much is disposed in the sea, regardless of regulations, and how much is disposed on the land. Shellfish waste is hardly processed afterwards. Now, the environmental impact that you asked for, it is both on the land and the sea. It has different impacts. And in the sea, you see the quality of water and the ecosystem can be really affected because you put so much of that material in specific places where it is dumped that it kills local ecosystems. On the land, you see the contamination of water and soil because it's all wet and it's all dripping and it forms bacteria and everything. So apart, you already call it funky smells. That is something here that is absolutely a big problem. We've processed shrimp, and Dan was there, and he said I couldn't even go into the airplane because the smell was all in my clothes. So anyway, and then there is, of course, because it's lying on the landfills, produces methane, ammonia, greenhouse gases in general. So that's not good. On the other hand, let me see. If you look at fish waste, there are actually a lot of interesting materials in there, the components. I'm not going into all details here, but if you make a kind of a general average, then you see on this graph that 70% is moisture and the rest are actually valuable materials. And in the center, you see some industries where all these materials can be used, from cosmetics, agriculture, food industry, and the pharmaceutical industry. So it is a wide market of applications where it can be used. And on the right, you see some fish. This was actually already rejected fish, was too old. And in the picture below, you see how it comes out of our system. So suddenly we make dry powder, as Doug already explained. Now, for the shellfish, we have the same thing. And in the shellfish waste, there is a lot of calcium organic matters. And the calcium is actually valuable. You can do a lot of things with it. And you see the same list here for shellfish waste. So there's a lot of things you could do with it, but not in the original form. It is now thrown away because nobody knows what to do with it and how to do it. But we know how to do it. We've done it several times, many times, and we get beautiful, odorless powders and fully sterilized.
And all without the use of fossil fuels, heat, or harmful chemicals through the process.
Ambient temperature.
Pretty incredible stuff.
The fact that it's odorless makes people's mind kind of blow when we explain this to them. It's actually fun to talk to people about this, but it's true. I mean, it's you can go from the nastiest feedstock material to something that looks like basically a fine powder, almost like a sawdust with no smell.
Well, and like we discussed last time when we had our issue about manure, or our live stream about manure, you know, in the surroundings of all these processing plants and in these landfills, the smell is horrible. People complain all the time. Yep. And we try to take that problem away.
Absolutely.
The producers call it the smell of money whenever something really stinks like that, right? From manure to seafood waste, etc. But we can keep the money component, just get rid of the smell.
Yeah, I was thinking I would much rather be near the processed via ADS material versus the starting raw material. No thanks.
It's a life-changing experience. Yeah.
All right, guys, let's pivot. Instead of seafood waste, let's talk about fruit pomace. So fruit pomace is all of that good stuff that's left over after processing fruits for juices, for sauces, for wines. We leave behind the skins, the stems, all of that good, nutritious stuff. And currently, it's being, again, some of it goes to landfills, some of it's being incinerated. Sometimes, depending on the setup, sometimes vineyards are selling their leftovers to farmers to use as livestock feed. Sometimes it's being used as fertilizer. It just depends on what the material is. The challenge, though, as we've already discussed, materials, when they're wet, weigh a lot. And heavy products cause expensive transportation costs. So let's talk about what processing those materials look like and kind of where that gets us, especially in the world of a circular economy. So what products can we turn that fruit pomace into?
Yeah, I'll take that one. And to build on your last point, the water weight not only makes it difficult to transport long distances, but it's also difficult to process on machinery on farm, if you will. And then on top of that, the current technology today is using heat. And we can't mention this enough. The fact that we're processing at ambient temperatures, retaining nutrient value, which in and of itself is a game changer. So coupled with the fact that you've got a whole bunch of producers that are looking for all sorts of new revenue streams while supporting the environment, because most people care about that. And the institution of carbon credit opportunity here is something, quite frankly, we don't talk enough about. And so this is a huge opportunity for people to enter into that space, purely because we're talking about a carbon neutral technology based on the lack of use of fossil fuels. It's just electric, as a reminder to everybody. So to answer your question directly, Chrissy, there's multiple different types of fruit pomace. You mentioned a couple before, I'll just name a couple. So for nutrient-rich animal feed as an example, apple pomace is a very, very common one here. The fact that we can dry it down without losing the nutrient value and create it into a fine powder, it's a huge benefit for livestock and poultry producers. And so it's what we're talking about here is increasing yield on farm throughout the entire supply chain. So that's what we're doing. So animal feed's a big one. That's kind of a common sense one. The other one people don't think about is fertilizer as much. You already mentioned fertilizer, so I won't go into that much. But the other one is specifically the bio-based materials. People ask me what that means. So bio-based products would mean like biodegradable. That's what that means. From a plastics to packaging material to even biofuels. And so it's a huge opportunity here. People don't think about that. But within the bio-based industry, this is a huge input into that industry. So anything to increase the yield is huge. And using as an example, grape pomace, Chrissy just mentioned, wineries and different things like that. You can find applications for this in various industries, from food to nutraceuticals to cosmetics to everything. So again, we're talking about circular-based economies here, reproducing the powder into something usable, high nutrient value, fine powder consistent.
All right, so let's switch and talk about the economic benefits, specifically for processors who are using the ADS technology to process fruit pomace.
Yeah, I can tell a little bit about that, Chrissy. Basically, all that material is just thrown away. All the pomaces are thrown away because you can't do nothing with it. It will rot very quickly because the skin has been broken and the material is useless. While basically, and I'll show my screen again, basically those materials, those products, those pomaces contain a lot of good elements. And if you see here, I'm not going into the details here, but you see this table showing all kinds of valuable organic materials that is in the pomace of apple and grape. And if you compact that all together, you see that there's still 45% moisture in that pomace. So if it is being transported, right, the costs are really, really substantial, because it most of the time it has to go a long way to landfills where you have the permit to dispose it. But more important actually is the orange section, the dietary fibers, all healthy stuff, and we throw it away. So in the middle section, again, you see some markets where the pomace can be used. Again, from cosmetics, agriculture, pharmaceutical, it is all there. Now, on the right side, this is more a bit of an illustrative thing. It shows what it does to people, what all these things that we throw away could do in your body, like lowering cholesterol, stresses, and making your immune system better by having more antioxidants. So what you see is actually a waste of healthy materials. The economic value of it could be, and we discussed that in the seafood waste, there we also throw away a lot of valuable materials. So imagine that you could process both into dry and clean powders and mix them together. You have fibers, you have vitamins, you have proteins, you have calcium, everything's there. So it would be a superfood for animals, for instance. Of course, I know this must be regulated a bit, but in principle, we can do it. Very simple, very easy. And so I think that if you combine all these things together, the economic benefits of using the pomace, like the fish waste, can be tremendous. And here you see a little bit, the pictures are not very clear because I had to enlarge them a little bit, but you see untreated pomace, and you see how it comes out from our machine, dry and powdered. And that is, I think, what can offer a great benefit to many industries.
Yeah, and if you think about the environmental impacts as well, Ari, and there's some overlap here with the economic benefits, right? So you already mentioned transportation costs, right?
Oh,
Reducing
yeah.
transportation costs
Yeah, yeah.
between 35 to 85% we're finding. But also there's carbon credits that can be gained, and in the US it's 161.8 grams per ton mile
Yeah.
of material that's moved. So if you can accumulate those carbon credits, you can sell those. So there's an economic opportunity there as well by reducing carbon emissions through transportation. But I also wanted to just mention, from an environmental perspective, apple pomace a year, 4 million tons are put in landfills. Grape pomace, 7 million tons. I figured you'd have a slide for this too, Ari, but you didn't. So I have to go off of what I know. 7
I have
million
to leave
tons a
something
year.
to you, Doug.
Yeah. 7 million tons a year of grape pomace going into landfills.
Yeah.
Just think about the methane that's being generated from rotting material in these landfills, right? And if you can capture that as a carbon credit or as a carbon intensity score reduction by comparing the current process to the ADAR process, there's huge value in that as well. And then lastly, think about the challenge we have in different areas of the world in expanding the existing landfills or creating new landfills because we're running out of space. And that's land that could be used for homes, to develop for homes, residential use, commercial use, or parks. Unfortunately, that land's being taken up by landfills. And I know some counties in Florida, for a fact, are really struggling with where they're going to build the next landfill because they have so much waste.
Yeah.
So there's definitely a cost environmentally in expanding and creating new landfills, but also a cost financially. So anyway, a lot to think about here.
Absolutely. And we do see a lot of crossover, especially when we're talking about reducing landfill waste, when we're talking about reducing greenhouse gas emissions, reducing transportation costs. We're seeing those benefits across every use case, right? So let's talk about our third use case for today, which is wood chips and wet bark. Okay, so according to, and I want to get this wording right, according to the American Forest and Paper Association, the US produces almost $300 billion in forestry products every single year. So we're talking about building materials, we're talking about paper, lumber, that whole spectrum. Of course, that results in a lot of waste. Just like the other materials that we've talked about today, wood chips and wet bark contain moisture. Moisture is expensive, equals heavy transportation, expensive transport costs. Rotting materials equal bacteria, equal emissions. It's the same story. We're noticing this trend, right? So let's talk about what it looks like to process wood chips and wet bark with ADS. All right, what can we do with wood chips and wet bark?
A lot.
That's a great answer, Ari. You care to elaborate?
That's it.
Yeah, we keep it short today, right?
In the webinar.
Well, shall I start or Dan when you
go ahead, Ari.
Yeah,
go ahead.
So again, I try to understand a little bit better what the magnitude of this is, and so if I did some searching, and what you see here is again the map of Europe. You know I live in the Netherlands, which is this orange tiny country in Europe. But why I show this is not so much to show where I live, but it's more to show that this country imports over 3 million metric tons just in fresh wood chips from Canada, from the US, the Baltic states, which are in the northern part there, above Poland, and even from Russia, although that has stopped over the last 2 years. And this is just used for energy. So biogassing covering 3 to 4% of our national energy consumption. Now, assuming that, let's say 25% comes by truck and 75% comes by boat from the US and from Canada, but it means that we need 75 million kilometers or 46 million miles on truck traffic between the Baltic states and the Netherlands. And this produces over 100,000 million tons of CO2. So apart from the cost, the environmental effects of it may be basically better than oil or coal, but the additional cost and the energy cost just for the transport, the human operational costs for the transport are tremendous. Now, but what you can do with it is dry it locally. So why don't we dry it in the source of in the countries of origin quickly, and you save half of it in transportation costs. So imagine those 46 million miles, and you could cut away half of that because you dry it locally instead of that you have to put it into a biogas installation, put a lot of fossil fuels on it to get it burning in the first place because it's soaking wet, right? And we make from the wet material, from the wet wood chips, we make dry, fluffy material. And I show you that how it looks like here. So these are the chips that come in. They use hammer mills to make it small, but it is still wet. And it comes out our machine like here, very dry fibers. So we fiberize it, I call it, right? And another application is, which is very interesting, I believe, is that you can make bio-friendly construction paneling out of it. And for instance, the largest Dutch building company, construction company, buys thousands and thousands of these panels in France where they make them, right? So you have, again, a lot of transportation costs. And on the other hand, the Dutch forestry department from the government, have millions and millions of pounds on material that they take out of the woods, fresh, wet, useless because it's wet. But if you process it with our system, and we have been in discussion with this company, and we plan to go further in research with them. If you make those fibers out of it and use a biodegradable glue, right, you can make fully bio-friendly construction panels in the build, and so they make their own building components based from free resources, and that means you have cheaper panels, you have bio-friendly panels, you have no transportation costs. So those are the two main applications that we see for wood chips.
Wow.
I think it's important. It's important to note as well that this problem is everywhere in the world. And even with forestry thinning, that's planned thinning of the forests, the government entities don't necessarily have a place to put this material that they're pulling out. Number one. Number two, they don't want to transport it anywhere. And so oftentimes they do controlled burns, which is creating just to get rid of it, right?
Yeah.
So instead, Ari, could you talk about the importance of actually pelletizing things, what you could do? I mean, the fact that you can pelletize it with our system as a result of our system?
You absolutely can. And although the fibers that you see here in the picture is still a little bit too big for real pellets. Yep. But when you pass it a second time, for instance, and it becomes smaller, it's perfect to pelletize. Like we have seen last time with the manure, right? That comes out as really tiny powders, less than one tenth of an inch, and fibers, I should say, combined with powder, and that's perfect to pelletize. So most materials that we process that are waste can be pelletized, will not rot, are sanitized, and can be transported.
And just for everyone's awareness, it doesn't come from the industry, because I certainly didn't years ago. The importance of pelletizing is so it's a consistent input quantity. So it's the very consistent upstream process into downstream procedures, into creating things such as energy. It's a huge use for creating energy, ranging from biogas to ethanol to hydrogen. So that's why pelletizing is important. Yeah. You want me to go through some of the economic benefits here? Is that okay, Chrissy?
Absolutely, go for it.
That's kind of what's on my mind here at the moment. Some of the economic benefits here. I mean, again, if a producer so chooses to simply just get rid of the problem cheaper, eliminating water weight is the same as all of our other use cases. It just makes it cheaper to throw away, and this is for both public and private sectors. Okay, and as a result, you can use less space. It's just as simple as that. So. Hopefully you're not just throwing it away and you're making something value added out of it. And we already talked through, basically the importance of biochar. That's the general terminology for it. It's not only just used for create products and energy and stuff like that, but it also can be used for soil improvement. Helps with erosion, and it's also a huge contributor for carbon sequestration, just to be clear, which has all the buzz right now as far as the absorbing of carbon in the air. So it's a big deal. It's quite frankly just another revenue stream for the lumber yards and for the entire industry. And quite frankly, that industry could use some good PR. There's been a lot of deforestation complaints for good reason around the world, depending on where you are. Some areas are more regulated than others. And quite frankly, all of these companies are looking for positive reputation PR. And so when they can say they're creating a circular use and they're not creating any sort of waste in their production facilities, that's a big deal. And it's creating more employment opportunities, et cetera. Part of the problem, again, is just the fact that when you produce wood products on site, it's very difficult to transport them. Either logistically, because you're up in the mountains, as an example, and it's hard to get a semi out of there, and you actually want to create, or quite frankly, it's just too heavy, which is the water weight. And so this is opening up an incredible amount of opportunities for both public and private sector.
Absolutely. All right, guys, we are running out of time. So let me check and see what questions that we've had come rolling through.
My favorite part.
You just never know. It's a coin toss, right? All right. Let's
keep the camera rolling,
see.
though.
Someday somebody's going to test your skills. All right. First question. Can ADS be integrated into existing processing facilities without significant infrastructure modifications? It's a whole lot of big words. Who wants to take that?
I think this is a perfect question for Doug.
Want to answer that, Doug?
How can it be integrated into existing infrastructure?
Without significant modifications is what the person's asking. Does it require a complete rework from an EPC perspective?
No, actually, it's fairly easy to integrate. I mean, once the unit is set up, it can just take the output from a pre-process and feed it directly into the ADS unit, and then take the output from ADS directly into the next step in their process, right? So it's very, very easy to integrate just by disconnecting whatever drying system is already there, if there is one, whatever type of a milling system is there, whatever type of a sanitation system is there. Usually those take up much more space than an ADS unit, and then just replacing that with a smaller footprint ADS unit.
All right. Let's see what else we've got. We have
the fact that it's modular helps a lot. Not just to throw in a quick plug there.
Yeah.
Largely because of Doug. All right.
Okay. Here's a good one too. What level of expertise or training is required to operate one of these units effectively?
Ooh, let me take that one.
That's my favorite question.
It's so simple, even I can do it. Say, all right, let's.
Okay, that's going to become our new slogan. ADS, so simple our CEO can do it.
Yep.
But not the CTO. It is too complicated.
So there's a screen. There are sensors. There are basically specs that you input into for the machine to run by itself. There are four buttons on the machine, and the entire operation is controlled remotely. as well. We have an entire back office that can monitor the machine remotely on your behalf. And we also have some new exciting stuff that we'll be rolling out shortly related to user experience, quite frankly, dashboard on your computer, but also real-time alerts on your phone for people so they don't have to constantly monitor the machine. So it does not require a full-time resource. Obviously, every operation will run its own way, but it's intended just for the machine to run 23 hours a day, and the 1 hour downtime is, quite frankly, just to make sure everything is working accordingly and according to OSHA standards. So it's very, very simple.
All right. So simple, our CEO can do it.
Yes, push a button.
Watch out. That's going to be next week's social media blast.
I'm trying to get Ari to put an easy button on there. No, I think we have to do some sort of royalty payment to Staples. I don't know, but yeah.
Okay. The fact that we have a significant piece of really cool equipment that has 4 buttons is pretty easy in itself. Okay. Let's not push it just yet. All right. Let's see what else. Okay. So this kind of ties into the last question. How does ADS compare in terms of efficiency and energy consumption compared to traditional drying methods?
Good question. Do you want to take that, Doug? That's usually it's usually a question to you.
Yeah, sure. Well, anytime you have a thermal drying technology, it's going to take more resource, more energy than kinetic drying or kinetic processes, right? So if you look at the science, anytime you compare a thermal dryer to a kinetic dryer, kinetic is always going to be more efficient. And we've compared a number of different drying technologies, including belt dryers and vacuum dryers and microwave and so forth. So there's a lot of advantages to the ADS over many of the fossil fuel types of dryers. And 99% of dryers are fossil fuel based dryers today, including fluid bed dryers and so forth. And then the few that are electric, there are some challenges with microwave dryers, for an example. You have arcing issues and so forth. So there's a number of advantages.
And those are batch systems, Doug. Batch-based system, not continuous.
That's right. Yep. So the ADS system is a continuous process. There's no stopping and reloading. Yeah.
All right,
Can
guys.
Could I also add, Doug, just one thing on this? The compulsory tax that we've learned so much about from customers all over the globe, even from places like Canada to California, on the usage of natural gas. It's not just the cost of the energy; it's the cost of the taxation on the type of energy you're consuming. Quite frankly, natural gas versus electricity. So it's a huge component and an ROI contributor as well.
Yep.
Well, and if I may jump into this, we're talking here in the Netherlands with a company that processes poultry manure, and when there was this conflict in Ukraine broke out 2.5 years ago, everybody remembers that gas prices, maybe not that much in America, but over here they went up 8 to 10 times. Yep. And this company had to shut down for 5 to 6 months because the gas was unaffordable for them. And so we are now discussing with them to completely switch over to ADS, because they don't want to have that uncertainty in future gas prices anymore. Mm-hmm. So you see that the impact of the energy consumption is enormous and will only get bigger in the future.
Very good point, Ari.
Absolutely. All right, guys, we are totally out of time. So if you did not get your question answered, make sure you've dropped it in the comments below, because as soon as we log off, we'll be logging on to respond to those comments and questions. And if you are interested in learning more about how ADAR's ADS technology can benefit your business or how it works within your specific space, reach out. Visit adartech.com. You can click the Contact Us button. We also have a calculator on our website that can help you calculate and get an idea as far as energy consumption, number of units, all of those things. A lot of our customers have found that calculator to be very helpful in preparing for an introductory call with our team. But we are always glad to answer questions. Be sure, if you are not already, follow us on social media and follow us on YouTube. You can find us across all platforms at ADAR Tech.